What's up, you cool babies? Today we're going to talk about vertex buffer objects. We're going to start on pipeline. The pipeline. Alright, I actually didn't save the slide I drew, but it's fine. I'll just do it again. But this time I'll fill it in one step at a time. So remember, in the pipeline, the first step was the data, right? The mesh data. And that data was contained in a vertex buffer object. So vertex buffer objects. Or a VBO. And again, just to recap, a VBO was a section of data allocated on the graphics card somewhere. All right. So how do we do this? So the first thing we want to do is generate one of these buffers. So I'm going to call GL gen buffers, which stands for generate buffers. And we're going to make one of them. And here it's a GL uint pointer. And this is the way that OpenGL is written. You know, in GLFW, for example, we're getting structs. We're using the structs to call functions and so on. We're getting like objects to work with. OpenGL was written a long time ago, and the way they chose to do it is that you don't get any structures. You almost don't get access to anything, really. All you get are handles, all right? So we're going to have handles to buffers. We're going to have handles to shaders. We're going to have handles to everything. And they are all uint, so unsigned integers. They have defined it here as GL uint, but it's just an unsigned integer. So fine. Okay, so let's make an unsigned integer in that case. We'll use the GL uint, and I'll call it buffer. And I'll pass that in. All right. So this first argument is n. So that's how many buffers do we want to generate if we want to generate, more than one. But right now we just want to do one, and then it wants the pointer to the uint to set to this handle, right? So after this GL gen buffers, this buffer is gonna be the handle that OpenGL has assigned to our new buffer. So let's run it, and let's just do it in debug mode so we can see. I'll set a breakpoint here in GL gen buffers. Make that run. So buffer is 1. All right. So that's not a very exciting number. But so 1 is going to be the handle to the new buffer that we made. All right. Great. So the next thing we need to do is to bind the buffer. Again, OpenGL uses all global functions. You cannot call, members on structs or classes or anything. It's all global functions. And that kind of includes its objects as well, that you call sort of a global function for buffers. And it's expecting you to only have one buffer bound at a time. So when you bind a buffer, all subsequent function calls are going to be working on that bound buffer. So we're going to bind buffer here. GL bind buffer. So the first is GL enum target. So it's so it's asking us which kind of buffer, because we're working with vertex array buffers, but there are many more types of buffers, like element buffers and so on. So we're gonna say this is a GL array buffer that we want to bind. And then the next argument is the handle to the buffer we want to bind, and we want to bind our buffer that we made. Cool, so now we should have our buffer bound, and now we can put some data in there. So again, here's the thing that the buffer doesn't care what kind of data it is. It has no knowledge of vertices or positions or normals or anything. It's sort of up to us how we want to structure things. So let's start with just we want to have just a triangle. Just give us anything. It's just like, because now we have nothing. So let's start with just like 2D triangle. Yeah, that'll do. So again, remember the normalized device coordinates. Here I'm gonna draw them out. The end is in our case, it's a square. It's actually a cube, but let's not don't forget it. You didn't hear that. And recall that it goes from -1 to 1 on the x-axis and -1 to 1 on the y-axis, where 1, 1 is the top right corner. So this top right corner is 1, 1. And this bottom left corner here is -1, -1. All right. So if we want to put a triangle here, let's just place it something like this. All right, so this is the triangle we want. Very nice. Okay, so what are the vertices gonna be here? So let's start with the top one. That's gonna be, okay, so it's smack dab in the middle on the x-axis is gonna be 0, and then it's a little bit up on the y-axis. So let's say it's 0.5 on the y-axis. And this vector down here is a little bit to the left and a little bit down. So that's going to be minus 0.5 on the x-axis, so it's left from the center. And then it's negative 0.5 on the y-axis, because it's a little bit down from the middle. And this one over here, a little bit to the right, so 0.5, and a little bit down, minus 0.5. All right, so this is going to be the triangle we want to draw. The standard struggle nerd triangle. So I'm just going to do this as simple as possible. I'm just going to put just the positions one after the other. So I'm going to make a floating point array. So let's just do float vertex data. So I'm just going to hard code this array here. So let's start with top one. So it's x0. And then it was up, so 0.5 in the y-axis. Then let's do the lower left one. So that's minus 0.5 and minus 0.5. So minus 0.5, minus 0.5. And then here we have plus 0.5 and minus 0.5. So plus 0.5 minus 0.5. There we go. Great, so this is going to be our vertex data. So we want to put these floats inside of GPU memory, inside of our vertex buffer object. And the way we do that is with the GL buffer data function. So its arguments are a GL enum target. And again, this is important to realize that this is the target buffer and not the buffer handle, all right? Because we bound the buffer handle here. So what it's looking for is, okay, which type of buffer are you trying to put data in? And then it will just pick the one that's bound for that particular type. So we're going to say this is the GL array buffer we want to put data in. And then wants the size. And again, it doesn't know if this is floats or ints or anything really. So it wants the size in bytes. So like how many bytes of data are you trying to put in here? So we'll use the size of vertex data. So that's just going to give us the size in bytes of this static array. Perfect. Remember, if you only had a pointer to this array, it just would not work. Then you just get the size of the pointer. This is specifically for static arrays that this works, the size of trick. And then it wants to point to data, so we'll just do vertex data. All right. And then there's this ominous usage. Like, what are you going to use this for? We're going to put GL static draw here. But this usage specifier is essentially where on the graphics card memory to put this data. And the way it decides this is, how are you going to use this? Are you going to use it to draw? And if you're using it to draw, then how often will you need to update it? All right. So if we're using it for example, a particle system, where it's like we're spawning a bunch of meshes and they might change and do stuff, we might want to change this buffer every single frame. We might want to update new data every frame. So then we want to put it somewhere in the graphics card where it's not expensive for us to update this every frame. But if we're, loading a model, or in this case we're making a triangle and we're not planning to change the triangle, then it doesn't matter where on the graphics card is put it anywhere there's space. So that's what static means. That static means we're not gonna change this buffer. And then draw means, yeah, we will draw. You can also do read. I don't know what that does. I'm gonna be completely honest with you. Actually I do know. It's for compute shaders and such like that. I think at least. Cool, and that's our buffer. And now we have data in it. And cool. So let's move on to the next step.